Let's bring up our next speaker. Paul Menning is the CEO of Business Accelerants, powered by Tech IM. He's going to talk about reducing the fuel consumption, greenhouse gas emissions, and medium and heavy-duty vehicles. So much that we talk about here in the state of California, which may be different than our national perspective, but it's a very important part of our economy, things going on. As I saw the video of Wally, I saw them all drinking straws, and I can only assume those weren't plastic. Get away with those. But back to Paul, his career started at General Electric, military products, medical systems, graduating from Massachusetts Institute of Technology, MIT, to those of us out here. Experience also includes 15 years with Eaton developing new products, growing business for industrial automation, military systems, and trucking. Ladies and gentlemen, nice morning. Welcome to Paul. Where are you, sir? There you are. Come on up here.
Good morning, everyone. I decided to borrow and modify some lyrics from Simon and Garfunkel in 1966 for the title of this presentation. Maybe you can help me with it. Slow down. You move too fast. You've got to make the... I'll bet you said morning last, but it really, for this presentation, is make the fuel last. Technology in transportation is constantly changing. It's often driven by government agencies to improve the safety of transport. It's also driven by governments around the world to make the environment better. Part of it is to make whatever fuel is used to move vehicles last longer by making the vehicles more efficient. We also need to make the vehicles produce less waste to reduce pollution of the air, water, and ground. If we are to last as a species, we need to have clean air to breathe, clean water to drink, and preserve the ground we walk on. This continual change in technology is helping in many ways, but it also is putting a strain on the people that must maintain vehicles and fix them when they break. If you are working on restoring a car from the 1960s, you may get away with a box of wrenches, screwdrivers, and pliers. I just read a story in the Wall Street Journal about a guy restoring a 1945 Ford pickup truck and how simple it is. If you work on a vehicle from the 1990s, you probably need a multimeter and a diagnostic tool. For the most recent vehicles, you need someone with an advanced computer and specialized knowledge of the tens of computers, multiple data networks, and hundreds of sensors. They almost need to be someone with the same initials as a doctor, an MD, where the MD stands for Maintenance Diagnostician. I know this because I've been pushing the limits of technology my entire career. While still at MIT, I worked on X-ray sensors for the first breast scanners. At GE, I worked on multi-computer systems for intensive and cardiac care centers, as well as the ultrasonic scanner that was used last week to take a picture of my granddaughter in her mother's womb. At Eaton, I worked on industrial automation, camera inspection systems, missiles, nuclear submarine controls, and automated guided vehicles. At Daimler Trucks, I worked on all aspects of the vehicle to make it safer and more efficient. I'm a long-term member of the IEEE and SAE, having helped set some of the many standards used in transportation electronics. I participate in the truck industry through the Technology and Maintenance Council and the National Transportation Equipment Association. I'm now the Executive Director of the Transportation Safety Equipment Institute, a 60-year-old trade association focused on lighting and mirrors. I'm the President of the National Transportation Center Foundation, providing scholarships for alternative education for careers in transportation. I work with startups of all sorts and help companies develop and implement strategies to improve results. I've also had the privilege to serve our country as a member of committees for the national academies looking at future technologies for transportation. Within the next few weeks, I expect the final report of the work of one committee to be published. It's got a really long name. Assessment of Technologies and Approaches for Reducing the Fuel Consumption of Medium and Heavy-Duty Vehicles, Phase 2. 20 people, including chief technology officers of companies like General Motors Powertrain and Cummins, professors at universities, and leaders of the national labs, collaborated and interviewed many specialists throughout the world. The report will cover a multitude of topics in tremendous detail in some cases. Basically, it covers the topic from soup to nuts. That means it goes from the beginning of a meal with soup to the end of the meal with a dessert of nuts. It covers the regulatory future directed by such agencies as the Environmental Protection Agency and the California Air Resources Board. Certification and compliance to avoid the problems we've seen with Dieselgate. Powertrain technologies and the many advances to improve from 35 to 48% efficiency to over 60%. Technology to reduce power demand, such as by improving aerodynamics, using low rolling resistance tires, decreasing the weight of everything, decreasing the weight of axles, and further improving their already high efficiency, and minimizing the energy required for heating and cooling the cab and keeping the driver entertained when off duty. The report addresses nearly every conceivable way of powering a vehicle down the highway. It addresses freight efficiency and what can be done with such concepts as longer combination vehicles and platooning. Future improvements from intelligent transportation systems to alleviate congestion and autonomous vehicles are discussed. Manufacturing improvements from pistons to batteries are discussed, since everything we do must have a cost-benefit. Societal costs and benefits as well as product costs and benefits are discussed. International approaches are compared, since most every supplier in transportation deals globally. Rather than bore you with the detailed contents of a 500-page report, let me share with you what I learned from my experience. The transportation industry exists to move people and material from point A to point B. There is much more to it than the vehicle. The current situation with tariffs is highlighting how much more is involved in making and moving anything. I'll touch on everything from mining and drilling for fossil fuels and scarce materials to preventing hazardous materials from entering the ground at the end of life. I'll address my experience of past timing of technological advances and what my prediction is for timing. I'll finish with the impact I see on technical education. People are more sensitive now to the overall impact to the environment and the economy from the original point of acquiring a power source to its end of life. What started as efficiency of the vehicle became the impact from well to wheel. It has now moved to a complete life cycle analysis from well to wheel to the world in terms of its impact to air, water, and ground. Fracking requires huge amounts of water and may affect the ground. Strip mining of rare earth metals is devastating in some parts of the world. Drilling for oil has always been a concern. People fight the establishment of new pipelines to help move the fuel from point A to point B because of the demonstrated risk of spills. Opponents of natural gas will cite the burn-off of methane. It may not be quite as vociferous as the presidential debates, but people will intensely argue to energy content and potential efficiency equivalents of every source of fuel. For instance, solar energy is not a perfect solution. It is much less efficient than a gasoline engine, and even less efficient than a diesel engine, and way less than an electric motor. It takes the mining of materials and use of gases to produce the solar cells. What comes out of the tailpipe is argued vociferously. Fuel cells output water, while diesels output nitrogen oxides and particulates. When that expensive lithium whatever battery finally dies, even if used in a secondary application for grid storage, what does it do to the Earth? We are still dealing with what to do with the waste from nuclear power stations, and now don't know what to do with all the plastic waste we have. I recall over 20 years ago teaching Boy Scouts that we need to take the plastic from a 6-pack of soda and cut each and every part of it into small pieces to avoid birds getting tangled in it and dying. In all the years I've been in transportation, the promises of the scientists, engineers, businesses, and salespeople have never materialized in the real world where fleets operate. With all the effort put in by companies to produce an exceptional vehicle, the driver still controls as much as 1/3 of the effect on fuel efficiency that the fleets see. All of us know, in our heads at least, that things work better when they are properly maintained. But how many of us do the necessary maintenance or even the recommended maintenance? When was the last time you changed the air filter on your furnace? Did you do it in the last year? Lab tests are repeatable, but the real world has very different loads and conditions. Traffic becomes a huge issue that defeats the efficiency and calculations. Capital equipment can last for years. I've been in factories where a machine built in 1920 is still producing parts 100 years later. Transportation products stay on the road or off-road from 30 to 50 years. With standards constantly changing, forcing equipment changes, this is a cost to society that many don't understand. I cannot make light of these things, as it is, indeed, a weighty subject. Trucks used to weigh less than 15,000 pounds and could then carry 65,000 pounds of freight. Today, the trucks may weigh closer to 19,000 pounds and be carrying a bunch of well-packaged toilet paper or styrofoam. The real world has to account for everything from the lightest loads to specialized heavy haul of steel girders and copper wire. I've taken numerous pictures of the contents of boxes in my front hall after UPS, FedEx, DHL, and the U.S. Postal Service have dropped things off. I've spent a good portion of my career trying to improve efficiency of freight transport. I'm shocked at the amount of space and air that comes in a 3-inch by 7-inch and 12-inch box used to deliver a single flat item that could have fit in a typical envelope. Power and torque matter a whole lot, depending on the weight and mass of the vehicle and load. If I'm climbing the grade of the Donner Pass, I care about the gradability of the truck to keep me moving up the hill. Worse, if I have to stop because of an accident, traffic in general, or an overheated engine, I care about the startability of the vehicle. At that point in time, I'm not as concerned about emissions. A whole separate set of rules also apply to being able to safely stop this vehicle. The vehicle manufacturer does not know what you will be hauling, so the brakes have to account for the worst case weight. Under the best of circumstances, a truck cannot and will not stop as quickly as a passenger car. The first fuels for moving freight were food for humans and animals, and wind for the sails of ships. It seems that we continue to create more alternatives for energy each decade. This list does not even include the nuclear power, which is rumored to have fueled the failed missile test in Russia last week. I've not included solar power or wind energy. Battery is a simple way of saying chemical generation of electricity. There are numerous chemical and material combinations for batteries. The Department of Energy tracks various metrics for each energy source. This includes energy equivalency and the current price, which varies around the world, state by state, and even from one municipality to another, depending on tax laws in particular. Earlier I mentioned that there is more to moving freight or people from point A to point B than just the fuel used during transport. Every business, and yes, every government, must find a way to balance the cost of doing business with the value created by doing business. Fleets, even municipal bus fleets, look at fuel, of course. Oftentimes, the labor costs are a bigger factor. That's partly why you hear so much about autonomous vehicles for commercial operations. Factories, hospitals, restaurants need materials delivered at the right time in the right quantity. The cost of materials changes regularly, whether we are talking oil, natural gas, or lithium. Fleets, and we collectively, cannot afford to waste anything. That includes minimizing and eliminating mistakes. Yesterday, as I got within 10 miles of this resort, I was subjected to an hour-long traffic delay with thousands of vehicles' engines running with air conditioning on full, radios blaring. One accident that I never saw caused all this. I ended up following the lead of several cars before me. Even though my phone said I was within 1/2 mile of the accident, I had not moved for nearly an hour. I went off-road on the median and turned around. The ripple or domino effect of the accident still had me losing over 20 minutes on side roads. Speaking of traffic accidents, everyone is concerned about the cost of damage to their vehicle. Not only is the part expensive to replace, but it can take days to obtain, even with overnight deliveries. We might jointly argue about climate change and global warming. In my lifetime, I've seen the air in Pittsburgh cleaned up remarkably. I've seen Lake Erie go from being like a dead sea for fishing to being able to swim in it again. I've seen waste dumps become ski hills. We only have one world. We cannot waste it. When Marco Polo was moving spices by caravans of animals from China to Europe, he could not have imagined today with how we move materials from country to country. Just getting a message from one place to another took many months, even years. Not so today. We demand instant information everywhere at all times. We want the information to be accurate and unfiltered by using advanced mathematical algorithms using blockchain technology. Just over 60 years ago, the first satellite was put into orbit. Satellite tracking of things started soon after. 30 years ago, the Global Positioning Satellite System was operational. Today, multiple arrays of satellites are in orbit or planned in the next decade. Without it, I would not have driven from the John Wayne Airport to the resort here. Telematics allow me to provide information to just about anyone, even hackers that I don't want to have it. Being able to keep things going is getting more difficult. Predicting when something needs service will help fleets to minimize the downtime. Remote diagnostics helps to pinpoint the problem more accurately. I'm sure many of you have called in for service on your computer at home and given permission for the person to remotely control and look at things. Over-the-air updates to any of the computers on a vehicle sounds great, but maintaining the proper operation among a multitude of computers that are updated asynchronously has some pitfalls. Radio frequency identification and other methods help us to track things when there is no power readily available, such as in the thousands of containers on ships on the ocean and in the Suez and Panama canals. You'll travel 25,000 miles to circumnavigate the globe. If you did not sleep, stop to eat, or take care of biological needs, it would take you a year to walk that far. The International Space Station does it in 92 minutes. Christopher Columbus took 10 weeks to sail across the Atlantic Ocean. Cruise ships now do it in 15 days. A jet airplane does it in 7 hours. It really is a small world. I'm not just talking about the time to get from one place to another. I'm really talking about the interests of governments around the world to preserve and protect our planet and way of life. Almost all of the nearly 200 countries in the world have signed the Paris Climate Agreement. A small number of the countries have not ratified the agreement, including the United States. Regardless of the status of ratification, businesses around the world have found it necessary to use it as a guide for how to produce transportation vehicles around the globe. This need to produce vehicles for global markets extends to every part of the vehicle, for proper operation of lights to standards for brakes. Countries that were once behind in some level of performance or standard have gradually increased expectations. I forgot to include a logo for the National Transportation Safety Board of the United States. It seems to me that they are called in to help investigate safety-related incidents everywhere in the world. It's especially true for aircraft. Some days I wish things were as simple as suggested in that Wall Street Journal article about a 1945 Ford pickup truck. Unfortunately, it is complicated and is going to continue to get more so. I offer myself as an example. I'm a hit at home. I'm the home integrated technology professional. I'm in charge of watering the plants and grass using 2 different multiple output devices. One is over 20 years old and still going, while the other is a few months old and one of the solenoid valves plugged already. The lights come on and go off at either set or variable times. I can use my smartphone to remotely check on things and change their status. Voice control is possible to play music and control the lights. My wife wants to die before me. She does not want to be left with all the technology I've put in place. Wheels and tires have been around for how long? The wheel was invented 5,000 years ago. Pneumatic tires were part of the first cars just over 125 years ago. Today they have sensors for monitoring pressure and temperature. Many trailers are outfitted with tire pressure maintenance pressure pumps and valves. Certainly that 1945 pickup had no computers. I don't think a car built in 1980 had a computer. Today, though, there are nearly 100 computers on a car. And whether we are talking about electrical connections for those computers, the thousands of lines of software in them, or something as simple as a nut on a wheel, safety recalls occur. There is no getting around it. It is complicated. I have to address one more topic, that's autonomous vehicles. You'll hear and read terms such as CASE for Connected, Autonomous, Shared, and Electric, or ACES for Autonomous, Connected, Electric, and Safe. They are coming, but there are lots of questions of when, how much, how safe, and by whom. What I hear and see is a whole lot of hype. That's an acronym for heady yarn for price earnings. There are now dozens of conferences worldwide and a number of magazines devoted to the technology. Suppliers are spending unheard of dollars to create the technology and test it. Countries and states are vying for leadership roles in the hope and expectation of creating jobs and garnering revenues. I see a lot of talk about technology that always looks cool. In December of 2017, less than 2 years ago, there were 49 companies on record licensed to do testing of autonomous vehicles in California. A check last week shows that number has grown to 63 companies, an increase of almost 30%. The whole area is fabulously exciting. Before you get too excited, let me tell you about my experience in the trucking industry with new technology. The classic technology adoption curve is shown in the upper left here. The innovators are the first to try enthusiasts and represent a small proportion of all potential buyers, just 2.5%. The early adopters are visionaries that like to be able to say, "Look what I did," and show off to others. They represent another 13.5%. The next 34% of buyers represent the early majority who carefully evaluate things. They are pragmatic and ask suppliers, "Why should I?" They want to know the life cycle cost and lots of other things before buying. The conservative late majority represent the next 34% of buyers. Often they say, "I should have tried this earlier. Look what I could have saved." Finally, about 16% can be classified as skeptical laggards who will adopt it only if they must, only if the government makes it a regulation or a supplier stops offering an alternative. For instance, Did you know that windshield wipers used to be controlled by pneumatics? I worked with a fleet in the early 2000s to get them to move to electric motor-powered wipers. We had to tell them we would no longer offer the pneumatic-powered ones. The bottom left curve represents a transportation technology that has not been mandated by the government. Most big rigs have transmissions with 10 to 20 gear positions. Drivers have manually shifted them for years. The first robotic mechanisms for shifting the transmission for the driver reached the market in about 1990. As of today, about 80% of trucks produced in the USA use the automated mechanical transmission. It's higher in Europe and lower in India and China. The upper right curve represents the technology adoption curve for a federally mandated technology, electronic logging devices for tracking driver hours of service. Still, it took 30 years in the USA to go from the first products to being used by everyone. Europe did the same, but earlier than here in the USA. Other parts of the world are not there yet. The bottom right is a set of curves from the North American Council for Freight Efficiency. For 10 years now, they have been tracking the adoption of technologies to improve freight movement. Most of the technologies, even in general terms, are still less than 50% adoption by the fleets involved. If we included all fleets, it would be a much smaller percentage of adoption. This tells me I can believe someone that tells me we will have lots of autonomous vehicles in 2050, 30 years from now. I'd expect to see about 20% of new vehicles having some level of autonomous operation by 2030. But I'm not talking driverless vehicles. I'm talking SAE Level 4 vehicles that can operate autonomously in only certain conditions. Whoop-de-doo! What does all this mean to you and to education for the future? I believe it means the future is bright for those that choose to go down the road. We are going to need more technicians with more knowledge about the vehicle, the operation, the differences, the complexity. You may have a maintenance degree and be doctors of maintenance. That does not mean you will need a 4-year degree in biology or even engineering. It may not even mean you need a 2-year degree. Those may well be of value and benefit to you. You will also need certificates of achievement from manufacturers of parts. My daughter is working toward a certification in life coaching. I have a certification from the National Association of Corporate Directors to demonstrate my competence and knowledge for guiding a company from the board of directors. Packard just this week announced the opening of another Technician Training Institute facility. They want you to know how to repair their vehicles, their engines, their instrument clusters. There are ways of learning today and for the future that were never envisioned before. They may well be more focused than general. I want you to remember just one word: learn. Learn something new. Never stop learning. Don't limit your options to 4-year colleges. Steve Jobs of Apple and Bill Gates of Microsoft learned on the job. I often tell people that Bill Gates went to the college down the street while I was at MIT in 1976. That college was Harvard. I graduated. He didn't. Look where we are today. I see 7 steps to get from where you are to being skilled. First, you must have the desire to improve yourself and your skills. Next, read about it or have someone tell you. Then see how it is done. Today, you can use resources such as YouTube to learn many things. Nothing replaces doing it yourself. You will never fail, as that is another acronym for first attempt in learning. You may be trying to do it yourself using virtual reality goggles, as I did a few months ago when I assembled a disc brake for a truck. I refer to these first few steps as hear, see, do. I had to have training for going through customs almost a decade ago now. First, they had me read something and told me what to expect. Next, they showed me a video of how it is done. Finally, they had me get up and use a terminal to do it myself. Even my 2-year-old grandson learns best by doing it himself and learning from his efforts, both good and bad. Next up the staircase is to check that you are doing it right. Then you are able to apply it regularly. This may be a test of some sort that gives you a certificate of mastery. But the true test is when you show someone else how to do it. The true test of whether you are skilled at something is if you can mentor or teach another. There's just one thing left. Go to it. Make the future bright. Learn every day. Make it happen.